Today let's try to solve another Leetcode problem, 815, bus routes. So let me first explain the problem. So we are given an array of routes. So inside of the routes array, so for example, index 0, so it means for the 0 bus, it can go to stop 1 to 7 and go back to 1. And when index equal to 1, so for the bus 1, so it can go to stops from 3, 6, 7 and go back to 3. And we are also giving a source and target. And the source and the target are just, we can say it as stops. So we have a stop 1 and we want to go to stop 6. Yeah, and we want to calculate how many buses we need to get from the source to the target. Yeah, let me explain this example into the whiteboard. After that, I'll go to the code editor to finish the coding. So if we cannot find a solution, so we're gonna return a -1. Yeah, let me first go to the whiteboard to explain the problem. So the problem will be like this. I will use the small circle as a representative of the stops. So the big circle will be buses. So we are going to calculate how many buses we need. Yeah, if we just as a person, if you can take this bus, if you, yeah, so for a person, if start from this point, maybe he can take several buses. Yeah, so for this problem, we need to translate the problem for a person to choose buses and not not the buses itself. We have to choose a person, and this point will be the stop. It's gonna be the stop to the buses. It will not be the buses to the stops, because if a bus go to the stops, so for example for this bus, it can go to many stops. Yeah, and when it goes to the stops, and there will still be many buses, but this will be difficult to calculate the result. So we're gonna first transform this problem to the stops to buses, and then the bus to stops. Yeah. So for this example, the small circle will be the stops. So the person will first start from the source. So this is the source, and then it will go from the source, from this stop, go to the buses, because this person can choose different buses. So for example, this person can choose bus 1, bus 2, or bus 3. And for each of the bus, it include, and for each of the bus, it includes all the stops, because we are giving a route array. Inside of the route array, it means how many stops the bus can go through. So for this bus, for example, this bus 1, it can go to 2 stops. So this is stop 1 and stop 2. And then from this stop 1, it means the stop 1 can choose many buses. So if it can choose buses, for example, can choose buses 4 and 5. So this means the bus cannot have duplicate. Otherwise, it will have infinite loop. So if the person wanted to choose the next bus, this person cannot go back. It have to be the forward. Yeah. Otherwise, this person can never go to the target. So we needed to have a check of this person cannot go back. So if this person wanted to go forward, he's gonna choose another bus, maybe 4 or 5. Yeah, if this person from this stop, maybe this stop is, let's just use numbers, maybe stop 1, or this is stop 2. This person, from stop 2 can choose another bus. So this bus is bus 4. And then from bus 4, if this bus is connected to the target, for example, target is just 3. So it means we find a solution. And how many buses we used? This is 1 bus, this is another bus. So it means only 2 buses. Yeah. So this is why we can use the BFS to solve the problem. For this kind of a BFS, I call it vanilla BFS because we didn't use the multi-source BFS or bidirectional BFS. We just use the vanilla BFS. But the difficult is to translate the problem. We're gonna translate the problem. The source and the target should always be the bus stops, and this is easy to understand. And for the BFS, we're gonna start from the stops. It means start from the sources, and the stops can choose any buses, and then the bus can still choose any kind of the stops. So for example, if from stop from bus 2, if from bus 2 this bus can go to another stop, and then this stop can go to another bus, maybe bus 6, and go to another stop and go to bus 7, and then go back to bus 4, and then go to the target. But how many buses we used? 1, 2, 3, and 4. 4 is bigger than 2, so it's gonna never be the result. Actually, for the BFS, while for the BFS loop through the 2 buses, and it will find the target. So it can never go to the 7. It can go to the 2 or 6, but it can never go to 7 or 4 because this is the longer. And for BFS, actually, this is the shortest path. And for each of the paths, it will be a cost of 1. So if this stop find a bus, so the cost will plus 1. From 0, it's gonna be 1. If find another bus, so the cost will become 2. Now let's go to the code editor to finish the coding. So we need to translate this problem into a graph. And for the graph, we're gonna start from the stops, and then from the stops we're gonna choose the different bus. So let's prepare this solution. So we're gonna first use the roots. Let's first define a variable z as the graph. So it's gonna be a default dict list. So this graph will be the stops with an array inside the array. So it will be the buses. So this will be the graph. So I'm gonna prepare a adjacency list. I think this is enough for this problem. I don't need to use a default dict set. I think a list is okay. So let's prepare the root. Let me first prepare the root. So for the actually I'm gonna put the buses inside. So I'm gonna use a bus. I'm gonna use a bus. So this bus means the number. It's gonna be number start from 0. So for the index 0, it is bus 0. For index 1, it is bus 1. So I'm gonna use enumerate. So for bus, let me use root. So for bus root enumerate the roots. So this is for each bus, it has a root array. And then I'm gonna choose R. I'm gonna choose a stop. So inside the root there is a stop. So for stop in root, and for the graph I'm gonna put the stop. And for each of the stop I'm gonna append the bus. So because I'm going to prepare a stop with buses array, so this will be an adjacency array, and this is my graph. And for each of the point, for each of the node, it will be represented as the stop. So for example, so I'm gonna have something like this. So this is a stop. It will be connected to several buses. And now I have another stop, and this stop gonna connect several buses. It will be like this. But how this bus and this stop is connected? Yeah, because we are giving a root variable. We are giving a root variable. So inside the root, we know if there is a bus stop. So we're gonna connect it. Yeah, so this is why. Now let me go to the code editor. So up to here, I get an existence array. So it's gonna be the stops as my k, and the array will be the buses. Yeah. Now let me prepare for the BFS. So I'm gonna prepare a queue, should be the queue. So inside the queue, I'm gonna prepare a source. So it's gonna be start from the source, and inside I will have a cost. So the cost will be 0. And I also need to prepare to visited set. I will not prepare it at the moment. Let me finish the main function. After that, I'll finish the visited set. So let's prepare the main function first. So while q exists, so I'm gonna pop it out. So I'm gonna use q dot pop left. Yeah. So it will pop out two variables. So first it's gonna be the let me use the stop. Yeah, it will pop out a stop, and then it will pop a cost. Yeah, so this means I gonna start from this stop. So for example, for example, I gonna start from this stop. If this is 1, I gonna start from this stop 1, and then I gonna choose the buses. And inside the buses, I gonna choose the different stops. Yeah. Now I can check the stops. So for bus in G stops. Yeah, because my existence array inside the stop, it is a bus array. So I'm gonna use let me use a buses. So let me just use a bus. Yeah, so if the bus inside the here, I gonna still also use the bus. Yeah, it means the different buses. Yeah, but I will use a singular because I will use the buses later for another variable. Yeah. So for bus inside the stops, so I gonna have a number of buses. Now I gonna use another loop. Yeah, I gonna check for this bus how many stops do I have. So because I used a stop first, so currently I have to use another stop. So I'm gonna use the s as my stop. So for s inside the root, inside the root bus. Yes, because bus is the index from 0 to n minus 1 maybe, and for root bus it means inside the root. It means my stops. So here I will use the lowercase s as the stops inside the root. Yeah. And what I need to do, I need to append something inside the queue. But what should I append? Of course, it would be a stop, and then the cost would plus 1. Finally, we're gonna need a tag. Yeah, we're gonna need a tag from here. So if stop, let's say, if stop equal to the target, so I'm gonna return the cost, right? And finally, if I didn't find an answer, I'm gonna return a -1. Yeah. So this is basically the main function, but this is not finished yet, as I explained earlier. So for a stop, if it can go from this S stop, start stop, go to the buses 1. And what's gonna happen from this buses 1? If we are not going to prepare a visited set, it means this bus 1 can go back from the source and then go to stop 1, go to bus 1 and go to stop 1, and there will be an infinite loop. It can never finish. Yeah. Let me first finish the function and then I'll approve it. Yeah. So this means I need to prepare some visited set. I gonna prepare visited bus and visited stops. Visited stops. Yeah, I'm gonna use visited bus and visited stop. So the visited bus should be the set, and visited stop would be a set. But inside, it's gonna have a source, because this stop has already put inside the queue, and it should also put inside the visited stop, because this source has already been visited. Yeah. Now from here, we need to put the bus inside the visited bus, because we never want to visit a duplicate bus. Yeah. For this one, if we visit bus 1, we never want to visit this bus. If we visit the 2, we never want to go back. Yeah, and also similarly for the stops. If we visited this stop 2, we never wanted to go back to visit it again. Yeah, we never. So this means, for example, this is stop 2, and if this another one is also connected, but we never want to let this bus connected to this stop. Why? Because if this is a cost of 1, if it is connected, it is still gonna be a cost of 1. It may be bigger. So this is why we never want it to connect. Yeah. So this can save much more time. Yeah. Let's go back to the code editor to finish the coding. So for bus inside, so if bus not in the visited bus, yeah. So what are we gonna do? Visited bus should end this bus, and similarly, we're gonna have another check for the stops. If stop, yeah, here is S. Yeah, if S not in visited stop, so the visited stop should end, because it is a set, so it's gonna add this S. Yeah. So this is basically the entire code. There's not so many lines of code, but we need a lot of analyze. Yeah. Let me first run it to check if it works. Yeah, there's something wrong with the memory. Let me check. Yeah, let me first print out this graph. Yeah, just have a double check if everything is okay. Queue and visited bus, visited stop, and for bus in graph stop, if bus not in visited set, so the visited bus should add the bus for S in route bus. Yeah, so there's something wrong with this route. Yeah, because this route is an array. And inside each one, it's gonna be an array. Yeah, let me first turn this route to another variable, to buses. Yeah. So I'm gonna use buses to represent the route, but I will use a set. So inside it's gonna be a set R for R in routes. Yeah. Now let me use the buses instead of the routes here, because basically for a set, it will be much faster than a array inside. Yeah, so I'm gonna use the buses with this bus. Yeah, it's still the same. Let me first check this graph tree if it is okay. So inside the graph, this is the stop 1 with a 0, stop 2 also 0, stop 7 and 0, 1, stop 3, it is 1. Yeah, this means the graph is okay. Let me check for the BFS. So I prepare a queue. It's gonna be starting from the source, and I also prepare a visited stop and visited bus. It's gonna be the set. Yeah, here also the same. And now let me check my main function from here. Yeah, so while queue, I'm gonna pop out the stop and the cost. If this stop equal to the target, I'm gonna return the target. And then for bus inside the G stop, if bus not in visited bus, visited bus should add the bus. For S in buses with the bus, if S not in visited stop, so the visited stop should add the S. Yeah, and the Q, yeah, I think this is Y. Yeah, because I put the Q in another line. I have to, yeah, I'm not sure. Let's just check. Yeah, Q should append from here. But I think it doesn't matter. Let me run it. Yeah, it seems okay. So this is something wrong. Yeah, while I'm running the function. So if this is not inside the visited stop, yeah, I should append it from here. But I make a mistake. I didn't. I didn't take notice of this one actually. I put it in another line. I don't know why. Now I think this should be okay because if it is not inside the set, I'm gonna first add this one, add it inside, and the queue should append this one. Yeah, but here I also did some things. So for example, for this buses, I turn it into a set. I just make it to run faster. Yeah, now let me delete this line and run it if it can pass all the testing cases. After that, I will do several tests. Yeah, for the program. Yeah, it's gonna take a long time. Let's just wait. Oh, there's something wrong. Yes, some testing cases cannot pass. It means it is still too slow. Uh, yeah, let me check why. What is wrong? Yeah, here is another mistake I made. You see? So first of all, I'm gonna check if the bus not inside the visited bus. So it should add this one. And for the for loop, I gonna go to the I need to go to just above the visited bus.add. Yeah, this is I think I made so many mistakes because I just writing the code. I finished the main function and then try to insert one line and insert another line, and then it interrupted my mind of what is the program and how it runs. Yeah. So because this for loop should start from here. If it is not inside, we're gonna add it, and then we're gonna use another for loop to check it. Yeah. Now let me submit it to prove it works. And then I'll analyze all my mistakes and do more testing for this program. Yeah, as you can see, it's pretty fast and it's nearly 90% of all submissions. And I believe this is the fastest one because we used the visited set to avoid so many duplicates. And the time complexity, let's analyze the time complexity. The time complexity actually is the yeah, I believe it should be the number of unique stops, and we never know how many unique stops. Let's check. Yeah, we have a root and we have a root I dot last, but we never know. Yeah, all the values of root I are unique. This is unique. Yeah. And here we have another variable. Let's check. So the sum of roots I dot less should less than and equal to. Yeah, let's check the root I. Yeah, so if there's no duplicate, the root I inside the root I, the length should be what? 10 to the power of 5. Yeah, actually this is the time complexity. It is 10 to the power of 5. Yeah, because we used the visited set to avoid any duplicate. It means the number of the unique stops inside, but we never know. We only giving the sum of the roots I, so it means the 10 to the power 5 is enough to let it pass. Yeah, and let's see the values. So the values roots ig is 10 to the power of 6. Yeah, so this means 10 to the power 6 is also enough. If there are like 10 to the power of 6 of unique stops, it can still pass. So I think if the roots I is even more than 10 to the power of 5, it is still okay, because inside the algorithm it's gonna check the unique stops. It's gonna be this one, 10 to the power of 6. That is why it can pass. Yeah. Now let's analyze my mistakes. So first of all, my first mistake is I didn't check this one. I've already explained this many times, but while writing the code, I didn't notice this one. So if we are not using the visited bus, yeah, so if I just make a comment of this line, this means we're gonna not use the visited bus. So what's gonna happen? So this means something gonna happen like this. Let me go to the whiteboard. It means it will go to for like this. So from the S, it will go for 1 and go back and go back. Yeah. So if the graph is not so complicated, it is okay. But if the graph is too complicated, from the source to the target, it will be a very long distance. So this is not okay. So we have to use a visited set for this one. Yeah, let me check it. So this is why if I make a comment, if I still, let me make a comment of, if I still use this visited stop, let me just submit it. It can go for some testing cases, it can pass, but it cannot pass all the testing cases. Because the branch will be too complicated from here. It will be many branches, so we have to use a visited set from this one. Yeah, as you can see, for a long time, it cannot pass. Yeah, let's check what's the result. I think it will be time limited. Yeah, as you can see, it can only pass 44 testing cases. Yeah, but this is okay. If I use this one, and if I make a comment of the stops, I can make the duplicate of stops. This means from here, this one cannot have duplicate, but for the stops, it can have duplicate. Yeah, but this doesn't matter actually, because yeah, at least we save some time for the stops. We don't need to go for the same stops once again. But we may go to the, I'm sorry, we don't need to take the same bus again. Like we take a number 1 bus, we take a number 2 bus, and then we are take a bus number 1. Yeah, this means it's a long distance. But for another thing, if we take the same stops, for example, if bus 1 takes the stops 1 and bus 2 takes the stops 1, yeah, actually we are using more time, but it doesn't matter. It can pass for the Leetcode. Yeah, now let me make a test for this one. This means we can go for the same stops. Yeah, as you can see, it is much slower. It comes from 0.1 seconds go to the 1 second. It is much slower. Yeah, if you are not using this. So this is why the best method is we should use a 2 visited set. Yeah, now let me just run it to prove it is okay. Yeah, as you can see, it is just 0.16 seconds. It is much faster. And yeah, this is all for this BFS problem. The difficult part is we need to turn this problem to a stop with buses. Yeah, turn this to a adjacency list. And after that, we're gonna just use a normal BFS. But inside the BFS, there are 2 for loops. We need to take care of the visited set. Yeah. And I also prepared another one. So if we are not going to use the buses, if we are not turn this to a visited, yeah, if we are not going to turn the routes to a set, basically we can turn it to a set to save time. But if we are not doing this, let's check what's gonna happen. So here it's gonna be inside the routes. Yeah, as you can see, before this time is just 01 because for s inside a set it is 01. Now it's inside an array. So the length of the array, let's check the length of the array. It can be yeah, I believe it can be very long. Yeah, and how many stops of the bus? It can be very long. Let me first yeah, there's close some tabs inside to check how many stops inside. Yeah, I cannot find. Yeah, and for the roots I dot less, roots I and roots I dot less, and yeah, as you can see, it can have 10 to the power of 5 stops. Yeah, if I use this one, I believe it cannot pass. Let's just make a test. This one gonna be the roots. Yeah, because the time complexity will be much more. It can be 10 to the power of 10. Yeah, let's just try. It cannot pass, I believe. Maybe. Yeah, yes, it can pass. Yeah, this is the strength. I tried to optimize the user set, but actually it can still pass if I directly use the roots. Yeah, I think it doesn't matter. Yeah, but it's better to use a buses set. Yeah, so it is set inside the root I dot length should be 10 to the power of 5. If this s, if I wanted to check if it is inside an array, normally, yeah, it cannot pass. Why it can pass? Because I think I used the visited set. Yeah, let me just delete, make a comment of the visited set. I believe it cannot pass. Yeah, because let's see. Yeah, it can still pass. Yeah, it can still pass. It's the same. I don't know why. Yeah, but anyway, let's just make it to a normal solution. I use buses as a buses set, and yeah. Yeah, thank you for watching.